So I'm Andy Haskell, and welcome to my talk on making terminal UI apps from the ground up with the up-and-coming Bubble T framework. So before we get into the talk, I just wanted to introduce myself. I'm Andy Haskell, a senior software engineer at Salesforce, and at work I primarily code on backend. I've been doing that in Go since 2015, and I'm also one of the organizers on the Boston Go meetup. You can follow me on Mastodon at andyhaskell@mastodon.social. And additionally, in addition to the back-end stuff, I'm also a self-taught front-end engineer since 2017. I got into the Vue.js ecosystem as my New Year's resolution that year, and after powering through a lot of tutorials over the years and learning alongside the legendary Code Newbie community, I got pretty solid at writing web apps on the browser. And last year, I found out about a Go package called Bubble T, and instantly got way into it, not only for being able to write professional-looking front ends on the terminal and just being really fun to write, but also because it has the Elm Architecture, which I find really conducive to managing as much or as little complexity as your app needs to have. And that architecture you might find familiar if you've coded in React, Vue, or the Elm language itself. So in this talk, to demonstrate the process of growing a Bubble T app, we're going to build an app called Plamps, which is pupper speak for plants. And the app keeps track of when you watered each of your plants last. I was one of the people who got into plants as a pandemic hobby, but keeping track of all the intervals for watering the plants can be tough. So to learn Bubble T, I decided to make an app for tracking that. So to start, let's make a Hello World app, and that'll help us demonstrate exactly what this Elm architecture is all about, like why the front end community is like really raving about it there. So to make this visual, we'll start with a diagram of the initial version of the app that we're making, which is just a static list of our plants that need to get watered, and when they were last watered. And when I make a UI, whether it's in the browser or in the terminal, I find it useful to have a handwritten mock-up so that after I doodle what the app looks like, I can then just go back and highlight which parts of it need to be reflected in some code changes. And in the Elm architecture, well, the idea is the app's logic lives in three areas: model, view, and update. And the model contains all the data that represents the state of your app at the current moment. So for the app we're building, one way we might represent the model data is by using a slice of objects representing the names of our plants and when they were last watered. The view in Elm architecture is the logic that tells us how to render all the components of the app's UI based on the model data. So initially, the view logic just shows a block of text for each plant. And then finally, update is our logic for processing all the input our app gets. In the Elm architecture, we process those updates one piece of input at a time, getting an update and reflecting it in the model accordingly. So then that gets propagated to the view so the user sees it. And initially, the input we're processing is just the user pressing Control-C to exit the app. But later, though, we're going to be processing input like, for example, pressing Enter to water a plant. And in Bubble T, all that Elm architecture logic is contained in one interface called model, which is surprisingly simple and flexible. We're using just three methods: init, update, and view. For the initial model data, we're going to need a type to represent a plant, so we'll start there with our initial type, plamp. Each plant has a name and a timestamp for when it was last watered. And we'll also give it a days since last watered method, so we can say when the plant was last watered in terms of number of days ago rather than an absolute date. So we're returning a Boolean so that if time last watered is the 0 value for time, we can just return false, so the 0 value represents that a plant hasn't been watered on this app yet. So for initial hard-coded data, so we have some data to reflect in the front end, we got a pothos vine that was last watered today, a snake plant that was last watered 3 days ago, and an aloe plant we just got at the garden center and need to water. So with our plant type defined and our hard-coded data defined, let's go use this in the model implementation. And since our initial Hello World app is just a list of plants, the only struct field we need right now is a slice containing those plants. As for the init method, that's for doing any sort of asynchronous setup, that our app needs, such as loading data. since our plants currently are hard-coded in the app, we don't actually need the method to do anything, so we just have it return nil. So now let's move on to the view method. In Bubble T, since our apps are in the terminal and each cell in a terminal is one character, the job of the view method is to return one big string to represent the app. So since we're rendering a list of plants, we're going to make a strings.builder, and then in a for loop, we add a block of text, like a block of text about each plant, and then separate that by 2 new lines, and finally have a line that says, press Control-C to quit. And then for plant view, here's the helper method for displaying that block of text. We have a string with 2 indented lines, one for the plant's name, and then the other for when it was last watered. And we're also adding a helper function, plant last watered, that tells us, that gives us a string representation. So if we haven't watered the plant on the app yet, then we have in all caps, not yet watered. If we last watered it today, then we display last watered today. Otherwise, we just say how many days ago it was last watered. So we got the model and the view, so now let's move on to implementing update. We'll take a closer look at update's function signature in the next section, because that's where update gets really interesting. But the basic summary is that the thing it takes in is a message, the thing it takes in is a type called message that represents some input. And then in the update method, you get a switch statement on the type of message that we get, and that helps us decide, that's how we decide how to process the input. So in the switch statement we have right now, we check if we're processing keyboard input. If so, we check if that keyboard input is the user pressing Control-C, and then if so, then we return t.quit to exit the program, and then otherwise we just don't do anything at all with the input. To run the app, we need to pass our model into t.newProgram, and we're also passing in one other value, like an option called t.withAltScreen. And what that does is it tells the Bubble T program we want to display the app in the entire terminal window rather than only below the command line. So if we compile the code we got so far and run the app, then we'll see our list of plants. So next up, we're going to make this app more interesting by processing arrow key input to move a cursor around and the enter key to water plants. So in the diagram for that step, the model data that we need to have is an index for the cursor, and then for the view logic, we're going to add on the plant that the cursor is over, we're going to display as the cursor a plant emoji, and finally for the update logic, we're going to handle moving the cursor with the up and down arrow keys, and then watering a plant with the enter key. So first up, on the model data, the only change we need to make is that we need to add an integer selected plant to say which plant we had the cursor over. And with that, all the changes to our model data are all set. So we can move on to writing the update method. But first, let's take a closer look at the method signature. So in the update method, everything we pass in and return is a Bubble T type. Like we talked about the message, which is an interface to represent user input, and then the return types are a model and a command, and we'll talk more about what a command really does in the next section, but regarding the model we return, that represents our app after updating it using the logic based on what message we got. So when a Bubble T app gets an update, a message goes into the update method, handles the message, and then that possibly updates the model's data. We return the updated model, and then the view method displays what needs to be displayed based on that. But what is a message exactly? That's a good question. A message is anything we want. It's the empty interface type. Message represents some sort of input, so different types of messages carry different data depending on what information a message represents. So for example, there's the window size message type for when the app's window got resized, or we get one when we also get it if we open the app for the first time. It tells us the width and height of the terminal window in terms of number of cells. I haven't used it yet, but there's also a message type for mouse input, so you can say like which cell someone clicked on and whether it was a left click or a right click. And the one we're going to process is a type called key message, which represents either a key or combination of keys that got pressed. So we've already got one for the Control-C combination. So we need to do, in order to handle the arrow keys, add new cases for when the message's string representation is either the word up or the word down. So if the user presses up, we decrement the selected plant value to move the cursor up one spot. If they press down, then we increment it to move the cursor down one spot. Now, we just need to add a couple code changes to process the enter key. In the plant type, we add a water method to set the time last watered value to the current timestamp. And then inside the update method, if we get the message of the user pressing enter, then we call that selected plamp's water method, unless of course the list is empty, in which case we don't want to do that because then we'll get an out of bounds error. So now that we've implemented our update logic, we're on to updating view. And the logic we need to change for view is basically all in the plant view method, where we want to display a plant emoji to use as the cursor. So first up, plant view needs to know whether the plant we're rendering is the one that the cursor is over. So we'll need to pass in the index of the current plant that we're rendering. And then inside plant view's code, we're going to add an if statement, like this is the code we had so far. We're going to add an if statement based on whether we're on the selected plant. And if we're on the selected plant, then we display the plant emoji rather than just spaces for indentation. Finally, in the top level view method, we just change the for loop to pass the index into plant view, compile that code, and we've got the cursor navigating with the arrow keys and the enter key to water our aloe plant. So it's cool that now we've got the enter key working, but the app isn't that useful if we're only working with hard-coded data. Right now, if we water the plant and then if we water a plant but then exit the app, we didn't save any data, so it's like we never watered any plants. We want to have it so our data can be saved and loaded in some sort of storage. And if this was a production app, I'd be going for something like SQLite or BoltDB. But to keep this code simple for a talk, we'll just use a plain JSON file. And to interact with it, we're gonna need to see what the init function and command type are all about. So first, let's check out the diagram of the next change. So now the place we need to change to load data when the app first opens and save data when the user presses Control-S are in the model logic. We need to implement init, which is where we load the data. In the update logic, we're going to handle a message type for that loaded data, and we're also going to handle saving our plant data with Control-S. And then in the view logic, we just add the instruction Control-S to save. And implementing this, we're going to take our first real look at the bubble T command type. So let's take a quick detour to talk about what exactly that type is. A bubble T command is any function that returns a message, and that message can then send some data to the app that we process in the update method. So what we're going to do is we're going to have a command that returns a message containing the data we loaded from plamps.json, so then it can be added to our model data. And if you look at the source code of bubble T, by the way, which I recommend doing, you'll see that that these commands are run asynchronously in a Go routine, and the reason for that is very similar to the setup for the event loop in JavaScript. Your command function is run separately from the app's update method, and what that means is that if a command is running really slow, like if your command is talking to a web server, even if you're talking to a web server on dial-up, your app doesn't freeze while you're waiting, and the modem is playing dubstep. It keeps running and processing messages. And by the way, command is not just for I/O. It's also you're also able to use it for animating components, like for example, if you have a spinner component, you can have a command that runs time.sleep to send a message and then move the animation to the next frame. So for our init method, we're going to return a command called load plamps, and here's how we implement it to load it from plamps.json. First, we open the file, and then we deserialize its contents from JSON using my personal favorite if statement in Go, handling the error for json.newDecoder.decode. And then once the list of plants is deserialized from JSON, we return them in our bubble T message, which is a new type that we have called plamps loaded message. It contains the plants we loaded. If there's an error loading the data, though, if there's an error actually loading the data, like if we add invalid JSON or the file doesn't exist yet, we just would return nil. However, if this is a production app and we got an unexpected error, then I probably would display an error message to let the user know where all their clamps are. So now an update. We add a case in the switch statement for a new type of message, clamps loaded message. If we get that message, we set a.clamps to message.clamps. And with that, our app is now loading data, and for saving it, we just need one more change in the update method to write one more bubble T command. So this time, if the user presses Control S, we return a command that saves our clamps to clamps.json. So in that command, we either create or open clamps.json, and then if that happens successfully, we serialize the clamps.that file, writing over whatever was previously there since we opened the file with os.create. Since we're not, though, changing any data inside the abstract, notice that we're returning nil rather than a message. However, if this was a production app, I would probably have a message so that then we can process the message to briefly display either success or failure saving or loading the data. So now we have an app that can save and load data, but even with that plant emoji cursor, this TUI doesn't look that flashy just yet. There's a lot of TUIs out there that can do things like use text boxes and other UI components to have, with borders and background colors and text that's styled with color or bold or italics. And in the bubble T ecosystem, you can get that sort of customization to our UI with a package called Lip Gloss, which is sort of like the CSS of TUIs. It handles things like positioning, borders, text, and background colors. So first up, since Lip Gloss is a separate package from bubble T, we'll need to add it to our go.mod file with go.get. Now we got that, we'll start by writing a style for our plant's text boxes, which might look familiar if you've done CSS. A style is a type of lip gloss object, and as you can see, just like in a CSS style sheet, we have rules corresponding to each aspect of a UI element that we want to tweak. So the first two rules are about the border around the text box for each plant. We're going to set the border to a rounded rectangle shape using the border method, and we set it to white using border foreground. Then we add some padding to the box, so the text isn't just right at the edge of the box. Just like in CSS, you can specify the padding in upright down left order, and each number you pass in is a number of terminal cells. So by passing in 0101, we're padding the content. We're padding the content of the box from the left and right, one terminal cell each. And then finally, we also set the text in this style to white using the foreground method. Now we are also making a style for the selected plant's text box. So in addition to our plant emoji, we're going to add some extra indication we're on the selected plant with just two other rules. First, we override the white border to a green one using the border foreground method, and then using the bold method, we make the text inside the selected plant's box render in bold. Now, in plant text, we're making just a couple small changes. First, we dropped the leading spaces on each line. First, we dropped the leading spaces on each line of the plant's text box Since now the indentation is managed by lip gloss, so we don't need to add those leading spaces ourselves. Second, in our plant view method, it now looks like this. To use a style, like the way we use it is we pass a string that we want to format into the style's render method, and then that returns a string with all the style applied to it. So here, if our plant is selected, we render it with box style selected. Otherwise, we render it with just plain old box style. Finally, in the top level view method, we do a refactor to utilize one other convenient lip gloss function, join vertical. Now we don't need to count new lines between UI elements, since join vertical handles that for us. So we add a plant view for each plant, as well as the app's instructions to a string slice called UI elements, and then we pass that slice into gloss.joinVertical. And notice, by the way, that the first argument of joinVertical is this constant called gloss.left. That's for aligning all the elements we're displaying to the left. And there's also constants for aligning the UI elements to the center or right side of the window, or you could even pass a number between 0 and 1 to say like where, in terms of like a ratio to align the elements to. And if you're arranging some UI elements horizontally, by the way, there's also a join horizontal method in lip gloss that works exactly the same, but just horizontal. So now our app looks like this. It looks pretty cool. However, it would be more professional if those buttons spanned the width of the whole terminal so that they were all the same width. But for that, we need our app to know what size our terminal window is, and that means we need to add a bit of extra code to the model, view, and update logic. So first up in the model, we're going to add the width of the terminal window as a struct field that we keep track of. And even though we're not using it, I'm also adding a field for the height, because if this was a production app, chances are we would want to use the height in our layout. So I add the height field just to prevent technical debt. Moving over to the update method, remember that window size message we were talking about when I was going over different message types? We're adding that in our switch statement for processing messages. So now if we get a window size message from either the user opening the app or resizing the window, then we bring the width and height information into the app's model data. And finally, in the view, we're adding just one other lip gloss style. We're going to set width to a.width -4, and the reason for that -4 is so that the box for each plant fits in the terminal window. Since the border rule and horizontal padding rule each made the plant's text box 2 cells wider, so that the width was a.width, then the box would go 4 cells off the screen. So now compile the code, and you'll see we've got the buttons stretching the whole width of the terminal. Now our app is really looking professional. So now the next feature we're going to add is a text input component so that people can add new plants, but we're not going to be the ones writing that component. We're going to use a text input that's already made, and we're getting that from a repository called Bubbles. If you've written React or Vue before, you're probably familiar with importing open source UI components written by people in the community. And Charm Bracelet, who wrote Bubble Tea, they run one of those repositories called Bubbles. And some of the components in there are a table component for when you want to display data in a table with like columns and rows, a progress bar component for indicating the progress of some process, and the one we're going to add is a text input component for typing in some text. So here's the diagram of our changes. As you can see, we now have our text input component, which we'll need to add to our app's model data so that our app keeps track of its state, and then so that we can render that text box in the view method. For the update data, or for the update logic, now typing into the text box will trigger editing the text, while pressing enter will reset the text input and add a new plant to the list. But there's one other detail that's important now that we've got like more than one component. and that is that since we got the list of plants and the new plant input both receiving input from the update method, we need to know which component we're sending input to. In other words, we need our model data to keep track of whether the list or the text input is the focused one. So in the view, we want to clearly indicate which component is focused. So when the list component is focused, we highlight the selected plant in the list, and then when the new plant input is focused, then we highlight that component while highlighting nothing in the list, so that all the focus is on that input box. And finally, in the update method, we're going to need to handle toggling the focus state using the tab key and making it so that input only goes to the focused component. Like if you press enter while the list is focused, then we water a plant. If you press enter when the plant input is focused, then we add a plant to the list. And just like lip gloss, bubbles is not directly part of bubble T, so we'll need to go get the bubbles components that we're using in our app, in this case just text input. Then we add a text input component to the model data using the type textinput.model, which handles all the internal state and logic for that component. And also, when we use a text input, we want to initialize it using, not using its zero value, but using the function textinput.new. So we're going to add a new function for initializing our app as a whole, which includes calling textinput.new. Now we've got our text input. Let's add focus state to the model as well, and we're going to do that by making an enum type called focus state. And this enum type, each value represents a different focused component. However, this is not inherently part of bubble T. Rather, this is an approach that I've seen looking at bubble T examples, and I generally pick this for managing focus state when I'm writing a bubble T app. Moving on to the view method, now we're adding an additional UI element to gloss.joinVertical for our new plant input component. So it's going to display right before the line with our app's instructions, and we're going to write that component that component's display using a new helper function called new plant input view. So inside there, we write a string called, we display a heading that says add new plant, and then below that we render our text input using the text input's view method. And that is one example of how components and bubbles tend to follow a similar pattern to T.model, where they have a view method to return a representation of the component as a string. For styling this view, we're going to use the same lip gloss style that we defined in the last section for the plant text boxes. So if the new plant input is currently the focused component, then we return it with the box in green. Otherwise, we return it with the box in white. Finally, in the view method, we need some logic to represent focus state, because on the list component, because currently in the list, we always display the plant emoji in green box on the selected plant, which would get distracting if the focus is supposed to be on the text input. So in order to do that, we need to update the if statement by adding an extra clause, focus state equals focus state plant list, so that we only render the plant emoji in the green box when the focus state is on the plant list. So now our view handles focus state in our new input component. So finally, let's go thread that through the update method. So first up, now we got a focus state, we're going to add some extra logic to the case for plamps loaded message. If the JSON file is empty, like someone's using the app for the first time, then in addition to setting a.plamps, we also autofocus to the new plant input box, because there's just nothing in the list to focus on. Moving over to the switch statement for keyboard input, we're gonna handle pressing tab to toggle between focus states. When the user presses tab or shift plus tab, when the user presses tab or shift tab, then we call this new toggle focus state helper function to switch focus between the new plant input and our list of plants. So here's the implementation of toggle focus state. If we're in the new plant input currently, then we toggle focus state to the plant list. And if we're in the plant list currently, then we toggle the focus state to the new plant input. And a couple lines in those if statement cases that or switch statement cases that I really want to draw your attention to are the blur and focus methods on the text input component. And these demonstrate another pattern that you'll see a lot of in Bubbles. Internally, Bubbles components frequently manage their focus state, their own focus state, which is used in the internal view and update logic to control what the component looks like when it's focused versus blurred, and whether the component processes input. So, so when we switch focus to the new plant input, then we call the input box's focus method, and when we switch to the plant list, we call the input box's blur method. Moving on to the enter key, currently when we press enter, regardless of what the focus state is, what we end up doing is watering the selected plant in the plant list. So we need to change enter's logic based on what the focus state is. So so now we're adding an if statement based on focus state. So if the plant list is focused, the enter key goes to the plant list, so we water the plant that's selected in the list. But if the new plant input is what's selected, then and the input box has some text typed into it, we want to add that plant to the list, and we're also going to reset the input box's text to blank using reset. And we get the text in our text box using a method called value. And that's another idiom that you'll see a lot of in Bubbles components. There's a value method to retrieve the data that a component's in charge of. In the case of text input, that's the string that gets typed in. For the up and down arrow keys, we're also adding focus state here, so we only process the arrow key input when the list is selected. So now we don't respond to up and down input at all if the new plant input's focused. And finally for update, remember how I said the Bubbles components have view methods like t.model does? In addition to that, Bubbles components also have an update method so that individual components can process messages the same way that a Bubble T model would. And it works basically the same where we return the updated component. So now if you get a message, in addition to your top level app model processing the message, the individual subcomponents do too. So generally the pattern that I do when I write a Bubble T app is that I have a switch statement for the top level component to process the message, and then the message goes to the subcomponents, and the subcomponents process the messages that they care about. And notice, by the way, that we didn't wrap a.newplantinput.update in any sort of if statement around focus state. The reason for that is the update method of a text input component only actually processes the message if the component itself is focused. That's why the focus and blur methods are so significant in Bubbles. So now if we compile the code, what we get is a UI where we have multiple components and users can add in a plant, I'm adding in a fern in this GIF here. And one thing, by the way, that I would do differently if this was a production app, notice how we had to thread focus state through the arrow key input that only the list actually cares about. Now that our list is accumulating some of its own complexity, like having focus state and arrow key input, I can imagine it getting some more complexity, like now that we're adding plants, we could end up with more plants, like if there was a big sale at the garden center, yet more plants than fit in the window, so I would want to add some pagination logic. So if this is a production app, the next commit that I would write is probably to refactor the list into its own component type. And that way, the list logic is modularized, and things like arrow key input will only be handled in the list components update method rather than the top level update method. So finally, we're going to take a look at how to implement navigation to another page. Personally, I prefer the one-page layout, but just to demonstrate how you might implement navigation in a Bubble T app, we're going to put the new plant input on its own page. And it's important to note, by the way, that in Bubble T, there's no specific concept of page navigation, so it's entirely up to us how we want to implement it. And the way we're going to implement it is by writing a second app model. And so now when we're in the plant list page, you can press Control A for add to go to the new plant input page. When we're in the new plant input page, you can go back to the list page by pressing Escape or pressing Enter to add the plant to the list. And to understand why it is exactly that we can use the approach of one model per page, we have to look at the return values of the model interface's update method. So far, most of our update functionality has been focused on returning the same Bubble T model that we had before, just with some of its data changed. In the update method now, we're not limited to just returning the same model we had before. We can return an entirely new object of any type that implements the model interface, including a model for an entirely different page. So with the changes we need for our app, the main one that we need to zoom in on is that for our app, now each model's update method will have functionality to return the other page's model in response to keyboard input. So we'll start on the plant list page by adding a new case in the keyboard input for Control A. If we get a Control A input, then we return our new the add plant model that we're about to create, which we'll be defining shortly. And there's a couple of things I want to draw your attention to with returning this model. First is that we're passing in the list of plants to our input page, and the reason for that is so that when we return to the list page, we still know which plants to display in the list, and or if the user pressed Enter, add the plants to the list. The other thing to point out is that we're returning a command that returns a window size message, and the reason for that is so when we return when we return that new plant input page, we get the message right away, so that it can be used in our lip gloss styles to render the page. We could have just set the width and height directly. However, I prefer the approach of passing in a window size message, so the model itself can be in charge of processing the width and height of processing the window size using its own logic, rather than a different page's logic being in charge of that. Now, moving on to implementing add plant model itself, our new plant page has the list of plants we're keeping track of, the input component for typing in the new plant, and information about the width and height of the terminal. When we create the add plant model, we immediately focus the text input because this time around we only have the subcomponent for the text input, so we never need that input to be blurred. Moving on to update, we're displaying the header with some plant emojis as the title of the page, which we're going to display in green and in bold. And then below that, we display the new plant input, and finally we display the instructions for the page. And for the new plant input, we're basically using the same logic that we had when it was on the other page. However, for the input style, I decided to add one cell of vertical padding in addition to the horizontal padding because Now we've got less stuff on the page, so we want to like take up more space of the terminal. Moving on to the new plant pages update method, we follow the same pattern. Moving on to the new plant pages update method, we follow the same pattern as we had for the plant list page. In the top level page, we process a message in this case, the key and window size messages, and then we pass the message to any subcomponents. In this case, just the new plant input box. Overall, the update functionality is pretty similar to what we had in the list, but zooming in on the keyboard input we're working with, now if we press Enter or Escape, we're navigating back to the home page. And when we press Enter before navigating back, we also add a new plant to our list. And our navigation function is pretty similar to the one that we had for navigating from the list page to the input page. To switch pages, we return the bubble T model for the page we're navigating to, so that's the list page. And we also return a window size message. So compile the code, and we have our finished product, an app with the new plant input on its own page, so we can add a hibiscus plant, which I'm sure this sloth would be very happy about because hibiscus is one of a sloth's favorite snacks. So if there's any main thing to take away from this talk, it's how to implement a UI within the Elm architecture, how Bubble T's model interface gives us flexibility with only adding the complexity that we need for our app's model, view, and update logic. And also from that architecture, we get consistency on where the logic goes for processing and reflecting changes to our app state. But since a Bubble T app model is an interface, and an interface can do anything, we've only scratched the surface of what a TUI can do. For example, regarding those lip gloss styles, if you're writing an app for a terminal that supports true color, then you're able to do things like have gradients or things like buttons that have like a fade-in glow effect when they're selected. And speaking of animation, Charm Bracelet does have another animation package I want to try out called Harmonica for physics-based animation. And they also have a package like not animation, but it's like a Wish for SSH. And finally, since the command type is a function that can run any code, we're not just limited to talking to files, we also can talk to web servers. So thanks everyone for coming out here. And I hope this has gotten you interested in writing your own TUIs or components. If you do, I'd love to see them, so share them with me on Mastodon at andyhaskell@mastodon.social. And I'm planning on also writing some blog posts for covering stuff that I didn't get to in this talk, like how to write test coverage. So if you want to follow those, then check out my blog at dev2/andyhaskell.